Okay, now question number 34th. So in this question we have been given a multivariable function and we have to comment on its partial derivative and uh, its its differentiability. So if I look at partial derivatives, the definition of partial derivatives is del f by del x is equals to at any point x naught comma y naught, at any point x naught comma y naught is equals to limit h tending to 0 f of x naught plus h comma y naught minus f of x naught comma y naught divided by h. So this is the formula for the partial derivative. Now in this case I have my x naught comma y naught as 0 comma 0. So this value becomes 0. So the partial derivative just becomes limit h tending to 0 h into 0 divided by h square plus 0 square whole divided by h, right? So that is just going to be equal to 0. And similarly you will get del f by del y also equal to limit h tending to 0 0 into h upon 0 square plus h square whole divided by h, so that is also 0. Now when we talk about differentiability, so there is a complete formula for differentiability which I'll just show you in a minute. Okay, so the formula for differentiability of a function with in multivariable is just this one. Okay, so a function is differentiable at x naught comma y naught if both del f by del x exist and this other thing also holds true. But actually we don't need to go that far. Okay, we don't need to check this definition. Okay, this definition just says that this should be small f, actually small f at any point x comma y equals to f of x naught y naught plus del f by del x into change in value of x plus del f by del y into change in value of y. But continuity is a precondition for differentiability. But I am making a claim here that the function f of x comma y equals to xy upon x square plus y square for x comma y not equals to 0 comma 0 and 0 at x comma y equals to 0 comma 0 is discontinuous. At 0 comma 0. So to see the proof of this, I'm going to use polar coordinates. So we did this in class. Let x equals to r cos theta and y equals to r sin theta. So limit x comma y tending to 0 comma 0 f of x comma y is basically limit r tending to 0 f of r cos theta comma r tan sin theta. So this just becomes limit r tending to 0 r cos theta into r sin theta upon r square cos square theta plus r square sin square theta. So I am taking that r square common. So this is just limit r tending to 0. So r square cancels with this, the denominator, this thing becomes equal to 1. So this is just sine theta cos theta. And you see that this value is going to change for different values of theta. So for theta equals to 0, this is going to be 0. For theta equals to pi by 4, this is going to be 1 by 2. For theta equals to pi by 2, this is going to be equals to, for theta equals to pi by 2, this is going to be equal to again 0. So this value changes depending on what value of theta you take. So therefore my function f of x comma y is discontinuous.